Hello, everyone. I'm Andrew Buckwalter,
And I'm Tommy Boswell.
and today we're going to do a presentation on the Madonna Smart System. So our sponsor was Madonna Rehabilitation Hospitals. They're one of the nation's foremost providers for medical and physical rehabilitation. Their goal is to pursue creative and visionary approaches to healing. The problem that they approached us with is that currently clinicians spend way too much of their valuable time manually recording and entering data from patient therapy sessions and not enough time focusing on the patient. So they needed a way for us to reduce the amount of time that these clinicians were spending with the data, and that would allow them to spend more time with the patients and focus on the patients more. The stakeholders from Madonna, our primary sponsor was Dr. Judy Bernfield. She's the director of the Institute for Rehabilitation Science and Engineering, and she was our main point of contact within the Madonna institution. We also had Brandon Luthke as another sponsor. He's the director of hospital applications, and we went to him with any of our technical needs. He was in charge of helping us deploy our final project onto the Madonna systems and make sure that the security was good enough for their facility. We also had the opportunity of working with Thad Buster. He's an important stakeholder on the project and the chief research analyst at Madonna. We went to him with a lot of testing and verification for the hardware to make sure it was on par with current systems that the hospital is using. For our team, we had two people from UNL. Chris Bone was the project tribe lead, and Bill Browning was the project manager. We also had the opportunity of working with Paul Cooper. He's our project coach, and he's also the CIO at NRC Health. For our team's internal leadership, we had me, Andrew Buckwalter. I was the squad lead and product manager. I was in charge of making sure all the team meetings and everything in terms of organization was going correctly, and also making sure that the product was high quality and up to the sponsor's standards. I was also in charge of the software team. We also had Josh Martin, who created tasks for people to work on as the development manager, and he was the hardware team lead. For our software team, we had four people. We had Shishen Zhao, Tommy Boswell, Ryan Witkowski, and Ben Morris. They worked on developing the software, which mostly focused on the front-end web app, but there was also a lot of work with the web API and database. For the hardware team, we had four other people. We had Brian Borer, Alex Schmelka, Joy Novotny, and Dennis Feng. They were in charge of researching creative ways to solve the problems with hardware and developing the hardware to meet Madonna's standards. So, as I mentioned earlier, the problem that Madonna faced was that clinicians currently spend way too much of their valuable time manually recording and entering data from patient therapy sessions, and that they needed a way for the clinicians to spend less time looking at the data and more time focusing on their patients, hoping to make the therapy sessions better for the patients. The solution that we came up with is that we created a system to automatically capture, store, and display the data that the clinicians were manually capturing in real time. That way, the clinicians would be able to focus on the patients. Currently, we have 4 different metrics that we capture: velocity, cadence, stride length, and heart rate. And our system looks to add 2 more metrics in the future, which are pressure and some additional IMU measurements. And now I'm going to pass it on to Tommy, where he's going to talk about the solution in more detail?
All right. So to delve into a little bit more about what exactly the solution is, so the solution that we've built in the SMART system is a system developed to automatically collect various health-related metrics during a patient's therapy sessions. Because if we want to save those clinicians time, we want to have a really hands-off system that has minimal setup. So what we've done is we've integrated multiple sensors that can read these metrics in tandem, and then these sensors calculate meaningful derived data from the raw measurements that they produce, and then they will transmit that onto the database, and then we can display the data additionally in real time to the clinician so they can meaningfully build upon this data during the therapy session. And lastly, we also record both the raw and derived data in a database for research and later viewing. Now, to look a little bit towards the architecture of our solution, it all starts with the sensors who, when in use, are constantly and automatically transmitting data that they collect onward to the web API. Now, the web API is the major go-between for all other parts of the architecture. It transmits calls from the sensors onwards to the database where data is more permanently stored. Additionally, the web app makes use of the web API. During the clinician's therapy session, the web app is constantly making calls through the web API, which will grab data from the database and send it back onwards through the web app, where it can be displayed in real time for the clinicians to use. Now, some of the major technologies we've used in this architecture for the web app and the web API, a very heavy focus on C# and CS/HTML with some JavaScript as well, and some AJAX calls to transfer communication smoothly. The database is mostly performed and written in SQL, and the sensors heavily use Arduino technology and embedded C code. And here we have some screenshots of our web app in action. Here you can see the distance gate, stride length, and cadence table viewing. So that can get all kinds of useful data like velocity and the stride of the patient. And additionally, a very important metric in the heart rate sensor. Here you can see a live updating graph with several unique data points that can be hovered through and viewed through time. And additionally, an instantaneous heart rate that can be viewed at any time. And heart rate is one of the most important metrics for the clinicians, as it's a very important issue in the rehabilitation field currently to make sure that the patient is pushing themselves properly. Otherwise, the quality of care can really decrease. And here is a little bit about the actual physical makeup of our sensors. So here we have the velocity gates, and some of the most important components here are a SparkFun ESP32 thing board that facilitates a lot of the communication in the hardware, a TF mini distance sensor that gathers the actual data, and some RGB LEDs for just output and signal checking. And so what we do with these velocity gates is we permanently position them at various points. That's 0 feet, 10 feet, 25 feet, 10 meters, 50 feet, and 150 feet. And these positions are hard-coded as they're the most useful positions to use for the common therapy session trials that the clinicians are going to be performing. And here we have our IMU, pedometer, and heart rate. And some of the most important components in this hub here are the SparkFun ESP32 thing board, a SparkFun 9DOF Razor IMU, and a Polar OH1 heart rate sensor, which we communicate with using Bluetooth. And this whole module is designed to be positioned on the ankle of a patient, and meanwhile the heart rate is on the wrist of the patient to get a good heart rate reading. And this whole system will communicate its data onto the database. Now, some of the values and highlights that we've learned from this project. Our initial goal was, of course, to find a way to spend less time measuring patient details manually and spend more time focusing on the patient without getting caught up in the data. Now, some of the important additional values we've learned from this project is the task of collecting live data calculation and presenting live feedback. We've also worked quite a bit in having quick access to advanced statistics and presenting those in the web app front end in a meaningful way for clinicians to view them quickly and from afar. And we've also learned a little bit about how we can better tailor therapy programs to individual patients and how the sensors must be refined for irregular walking patterns and other extraneous details. And of course, we've worked a lot with data that provides valuable information for the researchers and clinicians at Madonna. And that, in summation, is the SMART system. Thank you very much.